Hello again, welcome to another lesson in geometry. Today we're covering section 6-1, the polygon angle sum theorems. Okay, so we have some vocabulary to start with. First one, underline the correct word to complete the sentence. In a convex polygon, no points on the lines containing the sides of the polygon is in the interior of the polygon. So you can think of it as the polygon can't have a dent in it. So cross out the polygon that's not convex. And the second one here, it's got a big dent in the side of it, okay? So that's a concave polygon. It's caved in one part, okay? All right, vocabulary builder part 2. So regular polygon. A regular polygon is a polygon that is both equilateral, so that means all the sides are the same length, and equiangular, that means all the angles are the same. So we know two of these really quickly. So we have equilateral triangle. All the sides are the same and all the angles are the same. Okay, and we have a square. All of the angles are the same. They're all 90, and all the sides are the same. Okay, so an equilateral triangle is a regular polygon with 3 congruent sides and 3 congruent angles. All right, underline the correct words to complete each sentence. The sides of a regular polygon are congruent. That's what makes it regular. All the sides are the same and all the angles are the same. So a right triangle is not a regular polygon. It does not have 3 angles the same. An isosceles triangle is also not a regular polygon. It only has 2 sides the same. So write equiangular, equilateral, or regular to identify each hexagon below. And you can only use each word once. So number 6, this is going to be equilateral. All of the sides are the same, but not all of the angles. So equilateral. Okay. Number 7, this is going to be a regular polygon. All of the sides are the same, but all the angles are different, and all of the angles are the same. All right. Number 8, this is an equiangular. All of the angles are the same, but the sides are different lengths. So all the angles are 120, but you can see that the sides on the end are the same, but those 2 ones in the middle are too long. All right, on our second page, we have theorem 6-1, the polygon angle sum theorem and corollary. So theorem 6-1 says this: the sum of the measures of the interior angles of an n-gon, so that means n-sided polygon, some unknown number of sides, is the number of sides minus 2 times 180. Okay, so let's take a look about why that is the case for a second. So if you have a triangle, how many sides is that? Well, that's 3 sides, and then we're supposed to times that by 180. So this is 180. Now we know for triangles that it has 180 inside it, so that works just fine. All right, for a quadrilateral, just draw a random old 4-sided shape here. Our formula would say 4 minus 2 times 180, which is 2 times 180. So that means there should be 2 triangles worth of angles inside of our polygon. And if we pick one of our corners, one of our vertices, and we draw a line to the other vertices, you can see the 2 triangles. So in here, these 3 angles add up to 180. And these 3 angles add up to 180. So there's a total of, notice this is a big angle to make one of the corners of the quadrilateral, of 360, because it's 2 180s in there. We could do the same thing with a pentagon. So here's our pentagon. We know our formula is supposed to be 5 minus 2 times 180. So inside of this pentagon, there should be 3 triangles worth of angle measures. And we can do it by connecting one vertex to all the others. There's triangle 1, 2, and 3. So 3 triangles times 180 would tell us the total of the interior angles of a polygon. All right. So we have a corollary that goes with this. It says the measures of each interior angle of a regular n-gon. So remember, regular means all the angles are the same. Is the total of the inside divided by how many angles there are. So this makes sense. If you have a regular triangle, also called an equilateral triangle, okay, then we know that there's a total of 180 in there. And if we divide by how many sides, we get each angle is 60, which is what we already knew. That's why it was a regular polygon. Same thing for a square. If we know that the total inside is 360, then if we divide by how many sides there are, it's just 4, we get 90-degree angles in here because this is equal to 90. All right. So when n minus 2 equals 1, so in other words, when the number of sides minus 2 is 1, then this polygon is a triangle. And when the number of sides minus 2 equals 2 this time, then we know that this polygon is a quadrilateral. All right, so 4 sides minus 2 will give us 2 left over. 3 sides minus 2 will give us 1 left over. All right, so finding a polygon angle sum. So what is the sum of the interior measures of a 17gon? So use your justifications below to find the sum. So our formula for the sum of any inside a polygon is n minus 2 equals 180. We have 17 sides in ours. So this is going to give us 15 times 180, and if you multiply that on your calculator, you'll get a total angles inside the polygon of 2,700. All right, number 12 says, draw diagonals from vertex A to check your answer. So what we're doing is we're just connecting all of these together to show that there are 15 triangles, just like what we did above. And then you can go through and count up all the angles for each triangle, which is 180 times 15 of them, and we get the same thing. So the interior sum of the 17gon is 2,700. So in this case, 15 triangles in there times 180 for each one, which looks just like this line in number 11. All right, so using the polygon angle sum theorem, underline the correct word or number to complete each sentence. Number 14, okay? The interior angles in a regular polygon are congruent. That's what makes it a regular polygon. All the angles are equal, all the sides are the same length, okay? So a regular nonagon, okay, so a nonagon has 9 sides, so it has 9 congruent sides. Okay, eight-sided is an octagon and a 7 is a septagon. Okay, so use the corollary to the polygon angle sum theorem to find the measure of each interior angle in a regular nonagon. So a regular nonagon is going to have 9 equal sides, and then we're going to divide by 9 here. So 9 minus 2 is going to give us 7 on top. We still have a 9 on the bottom. Okay, and then when we do this on the calculator, 7 times 180 and divided by 9, we're going to get each interior angle is 140. So the measure of the interior angle of a regular nonagon is going to be 140. So if I was to try to draw a regular nonagon, which I will not be successful at, each one of these should be 140. Problem number 3, use the polygon angle sum theorem. What is the measure of angle G in quadrilateral EFGH? So if you look over here, you can see we have 3 angles already. We're just missing 1. All right. So to do that, we're going to use the polygon angle sum theorem to find the measure of angle G when n is equal to 4. And this is because it's a quadrilateral, so there are 4 sides. All right. So the measure of angle E plus the measure of angle F plus the measure of angle G plus the measure of angle H. So the 4 interior angles should equal to the formula for the sum of the interior angles. So n minus 2 times 180. And in this case, we have 4 for the number of sides. All right. So on the left side of the next line, we're going to just replace E, F, and H with some numbers. So 85, 120, 53, but we don't know G yet, so we'll leave that one there. But 4 minus 2 on the right side will make 2 times 180. So if we combine up all of the numbers on the left side, we get 258. And then 2 times 180 will give us 360. If I subtract 258 from both sides, I'm going to get 102. So the measure of angle G is 102. So in the quadrilateral EFGH, measure of angle G is 102. All right. Okay. So next we have the polygon angle sum theorem. And the polygon angle sum theorem says this: the sum of the measures of the exterior angles of a polygon, one at each vertex, is 360. Okay, so I'm going to demonstrate that up here on this random polygon we have already. Okay, so first off, let's draw all the exterior angles, one at each vertex. So there's one exterior angle right here. Here's a second one right there. Here is a third one right here. And then here is a fourth one right there. Now these angles all put together, angle 1, 2, 3, and 4, are supposed to add up to 360. So I'm going to go ahead and try to show that works. So we'll do it in green here. So there's one of the angles. If I take the green one and slide it over here, here's a second angle. I'm going to take this green one, put it right next to it so it's sharing apart. Okay. And then we'll take this one and we'll put this right next to it. Notice we're not having to do any rotation or anything. It just slides in perfectly. And the same with the last one. Take this and push it over here, and it fits in perfectly. And you can see that this is now a total of 360 degrees because it makes one circle around the whole figure. And that's what's happening with exterior angles, is they are forming one circle around the whole figure. We're going around the figure in a circle and extending each line. So all the angles formed should add up to 360. Okay. All right, so in the pentagon below, the measure of angle 1, 2, 3, 4, 5, and should all add up to 360 because these are the exterior angles, 1, 2, 3, 4, and 5. Okay, so use the Polygon exterior angle sum theorem to find the measure of each angle here. So in this one, we have 120 plus 81 plus 72 plus 87 should equal 360. So the 72 was the one missing. The 4 exterior angles should always add up to 360 in a quadrilateral. So in a pentagon, the 5 exterior angles should always add up to 360. Okay, so we have the 90 plus the 56 was missing, and then the 75, then the 73, and then the 66. Okay. All right, problem number 4. Finding an exterior angle measure. Okay, so what is the measure of an exterior angle of a regular nonagon? So once again, we have a 9-sided figure. Okay, so underline the correct number of words to complete each sentence. Since the nonagon is regular, its interior angles are all congruent. They're not going to be right angles. Okay, the exterior angles are supplements of the interior angles. So remember, here's maybe an interior angle, the nonagon keeps on going. If I extend the side out, then this part plus the interior angle together should make 180. So the green one and the red one are 180, okay? And any angles that add up to 180 are going to be supplements. So since the nonagon is regular, its exterior angles are all congruent. Okay. If the interior angles are all congruent, then all the exterior angles are going to be congruent too. Okay. So the sum of the measures of the exterior angles of a polygon is always going to be 360. And a regular nonagon has 9 sides. So now we can answer our big question. What is the measure of an exterior angle of a regular nonagon? And to do that, we're on the back of the next, or front of the top of the next page, by the way. We're going to get 40 here. Okay, why is it going to be 40? All right, well, let's see. We have 360 total, right? So divide 360 by the 9 exterior angles. Okay, and that's going to give us a total of 40. So 360 is the total, and then we're going to divide it by those 9 angles that are on the outside. All right, so you have a lesson check here. As always, pause your video, try the lesson check yourself, and then come back and check over and see if you did it right. Okay, so we have a lesson check here. Error analysis. Your friend says that she measured an interior angle of a regular polygon as 130. Explain why this result is impossible. So we're going to use indirect reasoning to find a contradiction into what she said. So we're going to assume what she said is true, and then we're going to try to prove that it doesn't work out. Okay, so we're going to assume temporarily that you could have a regular n-gon that has an interior angle of 130. So there's 2 ways we could find the total angle sum. We could take the 130 and multiply by the number of sides. Okay, or we could do the angle sum theorem, which says that the number of sides minus 2 should equal 180. Now, these two things should give you the same number for how much the total interior angles of this polygon are, okay? So we could be able to set them equal to each other. So in this case, we're going to have 130n equals n minus 2 times 180. We still have 130n on the left side, but over here we're going to do the distributive property. So 180n minus 360. Okay, and then we'll go ahead and solve this for n. Get all the n's on the same side, so I'll subtract 180n from both sides, and this will give us 50n with a negative equals negative 360. And then we'll divide both sides by negative 50, and you get 7.2 for the number of sides. Now, that does not make sense. So we cannot have 7.2 for the number of sides because every polygon has a whole number 3 or greater. So explain why your friend's result is impossible. And this would be something like this. If each angle measure is 130, interior angle measure is 130 degrees, then the regular polygon would have 7.2 sides. Okay, but that is impossible. Because it should have a whole number of sides greater than or equal to 3. So you can't have a 0.2 of a side of a polygon. All right, that concludes our notes for the day. So check off the vocabulary words that you understand. So hopefully you have equilateral polygon down. That's all of the sides are the same. An equal angular polygon, that's all of the interior angles are the same. And a regular polygon, which is a combination of both. Okay, and then how well can you find the angle measures of a polygon? So that's talking about the total interior or the exterior. Hopefully you're in here somewhere. If not, you want to go back and watch the notes again. I'll see you in class next time.